Hello students, welcome to the course Digital Signal Processing. We are discussing today the topic that is DFT. So let's see what is a DFT as a linear transformation. So when we discuss the DFT as a linear transformation, we need to replace the value of x of k with the help of the value that is nothing but the Twiddle factor. So Wn is nothing but actually called as a Twiddle factor. So this is the equation of x of k, that is the DFT, in terms of the Wn, that is the Twiddle factor. Similarly, this equation is nothing but the IDFT in terms of the Twiddle factor Wn. So Wn is actually given by the expression e raised to minus j 2 pi by capital N. So it is also called as a, which is nothing but the nth root of unity. Now let's see some of the description regarding the how many complex multiplication and additions could be possible with the help of these two equations, which are just provided over here. One is for the DFT and second is for the IDFT. So when we note down regarding this, it is also possible to conclude some of the points, like we note that the computation of each point of the DFT can be accomplished by n complex multiplications and n minus 1 complex additions. Hence the n point DFT values can be computed in a total of n square complex multiplication and n into n minus 1 complex addition. So how it is n square complex multiplication, that can be identified from this expression. So n is ranging from 0 to n minus 1. So totally it is total n values we are dealing up with. Next, again here n is ranging from 0 to n minus 1, means total n values. So this is how n into n, it will be n square complex multiplication, and total this particular multiplication will be added again with another multiplication, that too for the single value of k equal to 0, ranging from 0 to n minus 1. But this is to be repeated not only for the k but also for n. So that is why it is mentioned here n into n minus 1 complex additions. Now let's see the next conclusion for this particular expression. It is instructive to view the DFT and IDFT as a linear transformations on sequences x of n and x of k. So DFT will be the linear transformation on sequence x of n and IDFT on x of k. Let us define an n point vector xn. So this xn will be defined for the input sequence, and that is for the range 0 to n minus 1, and n point vector xn of frequency samples and n by n matrix Wn. Now how it will be defined, let's see. In terms of the matrix format, this is essential to calculate some of the terms related to the DFT and IDFT, as well as to study the properties in a deeper way for the Twiddle factors. So this is where we can just draw a conclusion that xn is nothing but expressed in terms of the x of 0 till x of n minus 1. Similarly here, capital Xn is mentioned as capital X of 0 till capital X of n minus 1, because of the range, that is obviously 0 to n minus 1 over here, and here also it is same. Now the question comes, how to prepare this Wn matrix. So for the preparation of this very important Wn matrix, which is just mentioned over here, that is the matrix of Twiddle factor, if we just concentrate on this term, that is 1, how this 1 is evaluated. So for that one, let me just provide here the some instructions. This is nothing but the rows are indicated with the k. Let's say this first row is nothing but k equal to 0, second row for k equal to 1, like that. The last one is for n minus 1. So when we discuss it for the number of columns, this first column is for n small n equal to 0. Similarly, this is for n equal to 1, this is for n equal to 2, like that. This last column is for n minus 1. So this is what simply the idea behind the preparation of Wn matrix. Now let's see how to prepare this particular element as a 1 only. Okay, so for this element, if someone want to verify that how it is 1, so Wn raised to kn, that is what the idea here, Wn raised to kn. But how this Wn raised to kn comes, that is with the expression which is mentioned just at the start of the lecture, that x of k is equal to summation n is equal to 0 to n minus 1 xn wn raised to kn. But to prepare this wn raised to kn, right now for the first element, that is k is 0 and n is 0, so obviously wn raised to 0 means, in short, e raised to minus j 2 pi by capital N. This term, entire term, raised to 0, that is what the value. So if it is raised to 0, so obviously e raised to 0 will reduce the value to 1. So that is why this entire first row and entire first column is reducing into the value that is 1. But what about this second case? Let's see this second case, that is nothing but wn. In the second case, the k is 1, n is also 1. So when k and n both are 1, so obviously wn raised to 1, that is what the value we will have. So same is been verified at the last element of the second column. So this last element, it is nothing but k equal to n minus 1 and n equal to 1 value. So that's why it is given with the n minus 1, wn raised to n minus 1. So this is how we can easily obtain the reduction in the statement, like the statement which is just provided over here. Let me just show you. This is what the statement which we have seen. This is the statement. This particular DFT can be reduced in terms of the matrix format like this, which is here. So it will be reduced to this particular format. Let me just point out it. Where is that? Okay, this is what the format where it will be pointed out. So this xn, that is x of k, is equal to wn matrix into xn. So this is how this multiplication will result the n point DFT calculation in terms of the Twiddle factor. Similarly, in order to get the IDFT, we are simply writing it like xn is equal to 1 by n. wn star means the inversion of the Twiddle factor matrix into capital X of n means x of k. So this particular expression, if someone want to just verify with the earlier statement, it is nothing but actually the statement. Let me just highlight it. So this is what the statement which we can just highlight. So this statement is nothing but the IDFT. So 1 upon n, right now we are just mentioning here for this entire term, some x of k is nothing but replaced with the capital X of n. So this will be replaced by capital X of n, and the value over here, that is wn raised to minus kn, that is nothing but actually the wn star, because it is the inverted value. So this is how 1 upon n into this entire term, so that is replaced with a small xn, and it is nothing but the IDFT in terms of the Twiddle factor. So this is another way to calculate it. So this is very important expressions which right now we are looking into. First one is to calculate the endpoint DFT using Twiddle factor. Second is IDFT, again using the Twiddle factor, that is wn, but this time it is with the star, that is the conjugate. So whatever the jth term we are using in the wn, that will be simply replaced with the minus j value. So this is all about the DFT as a linear transformation. So thank you everyone, thank you very much. In the next lecture we will see some of the numericals based on the DFT as well as the IDFT. So thank you students, thank you everyone.